Hi, I'm going to explain this week's homework assignment. Last week I asked you to collect a data set and enter the data into Excel. And your data set probably looks something like this. You have one column in which the answers are words like this, and then you have three other columns with numbers. I just made up this data set. I just wanted to make up a data set that would look like the data set that you have. In my data set, I have number of siblings, number of TVs that each person owns, and commute time, or the minutes that it takes each person to commute to work. The first question asks, calculate the mean, median, and mode of each of your three quantitative variables. Or I could have just said each of the three columns of data that have numbers in them. How can you do that? You have to, if you're using Excel 2013, or the newest version of Excel, you can just go up here to formulas, go up to more functions, and then go to statistical. You can still do this with Excel 2010, but it'll be a little bit different. If you're using a different version of Excel, just let me know and I can help. So for mean, we go to average right here. It's close to the top. This comes up. Highlight the numbers in one column of data like this. Highlight all the numbers, and then click OK, and you get the answer. Before you do that, you have to make sure that you choose which cell the answer will go into. Then you have to choose an empty cell. For example, I couldn't click on this one and then try to get the average because it won't work because there's already a number in here. But let's say I want it to go in here. I go to more functions, I go to statistical, and I go to average. I highlight these numbers, I click OK. It gives me the mean of this column of data. Then I can click on I can hover on the bottom right corner right here, and then click, and then drag it across. And it gives me the mean of all three. Now I'll get the median. I go back to more functions, statistical, and I go down to median. These are all in alphabetical order. I do the same thing. I just highlight the numbers. I click on OK. And it gives me the median for number of siblings. Then I just drag it across. And I'll just have you do it this way when in your homework. I won't make you write down or type all of these numbers over again. It's fine as long as I can see them inside your spreadsheet. But it's important to actually calculate these with Excel, because one way I can tell if you actually did calculate it with Excel is I can look up here and see if it says average, and if I don't see the word average up here, it means that someone entered in the answer without calculating it with Excel. I'll have you label them like this: mean, and then median, and then mode. I go back to more functions, statistical, and I go down to mode. You can just go to mode single, because I just want you to get one mode. It's possible that your data set might have more than one mode, but I'll have you use mode single. This one right here. It says SNGL. Highlight the numbers, click on OK, and then drag it across. And that gives you the mode for all three of these columns of data. For this assignment, we're not doing anything with the first column of data that has category answers. We'll probably use that one in another assignment. So that answers this question. You don't have to actually write anything down here because you've already answered the question. The next one says calculate the standard deviation of each of your 3 columns of data. And then it says which of the 3 columns has the most spread. To get the standard deviation, just go up here, statistical, under more functions, and then go down to STDEV. Now the one that you choose depends on whether your data came from a sample or from an entire population. You have to think about which one you collected data from. If you collected data from, let's say, your entire family, then you did collect data from an entire population, so it would be P. But if you collected data from just a few people from a larger group of people, then it would be a sample, and you would choose S. And I'm thinking that most of you probably collected data from a sample. For example, if you collected data from friends, you probably didn't collect data from every friend that you have, so it would just be a sample. So I'll go to STDEVS. I'll highlight the data. When you do this, make sure that you don't highlight the answers that you already have here, because if you do that, it'll include it in the calculations, and it'll give you the wrong answer. So here's the standard deviation. I can drag it across, and I'll just give a label here. I'll say standard deviation. Now let's go back. It says which of the 3 columns of data has the most spread. That just depends on which one has the largest standard deviation. So for me, it's commute time has the most spread. These numbers here are more spread out than the numbers in these columns. So I would say under here, commute time has the most spread. And I could also say because it has the largest standard deviation, but I didn't really ask for that, so I'll just say commute time has the most spread. And if you said this, I'll assume that you mean because of the standard deviation. This says create a histogram of each of the 3 columns of data. So how would I do this? If you asked a question that would to which people would only give single-digit answers, like right here, number of siblings, people would probably only give me single-digit answers usually. Your histogram can just have whole numbers and not the class intervals like 20 to 29 and 30 to 39. For example, you could just have a bar for 1, a bar for 2, and a bar for 3. If that's what you're doing, then just look at what the lowest answer is. For me, it's 1. Just type in 1 right here, and then keep going until you reach the highest number. For me, the highest number is 5, and then stop. Now what I do is I go up to data, I go to data analysis. This should already be installed on your computer, but if it's not installed, you can go up here to file, go to options down here, and then go to where it says add-ins. Click on add-ins. Go to where it says analysis tool pack. Click on go right here. And make sure that there's a check mark next to analysis tool pack, and then click OK, and it'll install it for you. And then after you do that, it should appear in here. So click on data analysis, go to histogram, and click OK. After you do that, for input range, highlight number of siblings, which is the column of data, and then for bin range, right here, highlight the column column of numbers that you just made here, 1 through 5. Make sure you click on Chart Output so it gives you a graph, and then it'll give you a histogram right here. You see, since I entered in 1 through 5 for my bin range, it gave me a bar for 1, 2, 3, 4, and 5. So what can I do now? You can actually click on here where it says bin, erase this, and type in the name of your variable, like number of siblings, and it'll be in there. What if I have something where the answers aren't just one-digit numbers? What if the answers are two-digit numbers? In that case, you can create bins of 5s or 10s. It just depends on how spread out your numbers are. So if you try to do bins of 5 and you end up with way too many bars, like if you end up with more than 15 bars, then I would go by 10s instead, so you wouldn't have as many bars. Usually you want to have somewhere between 5 and 15 bars, but not more than 15. So what would I do if my numbers go from 10 to 27? No, actually 10 to 75. It would probably make sense for me to go up by 10s. So I would go, first I would have to find the lowest number. For me, the lowest number is 10. So my first bin would actually be 10 to 19. And then the next one would be 20 to 29. But what would I do if my lowest number wasn't 10? What if my lowest number was 19? Or what if my lowest number was 14? What would I do? In that case, I would start with a multiple of 10 that's just below my lowest number. So if my lowest number is 14, I would start at 10 right here. If my lowest number was 24, I would start at 20. So I'm going to go from 10 to 19 to 20 to 29, 30 to 39, 49. I'm going to keep going until I pass the highest value in the data set. I think now I passed it because now I'm at 79. Highest number is 75. So what I would do now is before I do this, I'm going to show you what I would do if I wanted to make intervals of 5 instead of 10. My lowest number is 14. So actually, let's change this. I would still start at 10, but now I would go 10, 14, 15, 19, 20, 29. No, wait, 20 is 24. And then 25 to 29. And I would keep going until I pass my highest number of 75. And eventually I would get up to 79 again, and then I would stop. So what if my lowest number was 8 instead of 14? If my lowest number was 8, then I would start at 5, and I would go 5, 9, 10, 14, 15, 19. Because if I'm going up by 5s, I want to start at the multiple of 5 that's just below my lowest number. So if my lowest number is 8, then 5 would be my starting point if I'm going up by 5s. But if I'm going up by 10s, then I start at the multiple of 10 that's just below my lowest number. So I'm going to do it this way. So I go up to Data, I go to Data Analysis, I go to Histogram, I highlight my input range for commute time, just the data values, not the values that you calculated down here. You don't include those. For bin range, I would highlight actually only the upper numbers in my class intervals. I actually don't use this column right here. The only reason why I type it in is to make it more clear, to make it so you can actually see what I'm doing. Chart output is checked, and it gives me a histogram. Excel actually only shows the upper boundaries. So where it says 19, it's actually 10 to 19, and 29 is actually 20 to 29. I'm not sure why it does that. In here I can type in commute time. And now I'm finished. And then I just do that for all 3 of these, and I get 3 histograms. If you want, you could just print out the histograms separately and then staple them to the back of the spreadsheet. I think that would be the easiest. So you could staple all this together. You could staple your answers on here to the spreadsheet right here with the values you calculated, and also staple the histograms that you created. So now this right here, it says for each column of data, or it says describe whether each column of data looks like it roughly follows a normal distribution. So let me look at some of my examples. I would say number of siblings does not look like it follows a normal distribution because it looks like it has a positive skewness. It looks like it's skewed to the right because it trails off toward the right. So under here I would say number of siblings does not look roughly normal. It looks positively skewed. Down here I say for each column of data that does not look like it follows a normal distribution, describe what type of non-normal shape it has. For example, do you see a certain type of skewness or a certain type of kurtosis? I saw a certain type of skewness, so I said positively skewed. I didn't really see a noticeable type of kurtosis, so I didn't mention kurtosis. Now I'll look at my other histogram. What was the other one? Commute time. Commute time also looks positively skewed. commute time does not look roughly normal. It looks positively skewed. And if one of these did look roughly normal, I would just say, for example, if commute time did look roughly normal, I would say commute time does look roughly normal, and then I would stop because there's nothing else for me to explain. But if it doesn't look roughly normal, then I have to explain in more detail why it doesn't look normal. I still need one more histogram for number of TV zone. Number of TVs only goes from 1 to 4, so I'll do it just like I did over here. I'll just type 1, 2, 3, 4. I'll go to data analysis, in histogram. I'll highlight the data for number of TV zone, for input range. For bin range, I'll highlight my numbers here, 1 to 4, and I have to make sure chart output is checked. Now it gives me this histogram. This histogram also doesn't look normal. It looks positively skewed because it drops off down here. So I would also say positively skewed. The number of TVs does not look roughly normal. It looks positively skewed. And for kurtosis, you just have to look at whether the bars have a really tall peak or if they're really flattened out. For example, if these two bars went up really high and there was a really large drop-off down here, I would say that it looks like it has a positive kurtosis. And if it was really flattened out, like if these bars were a lot shorter, I would say that it looks like it has more of a flat negative kurtosis, but I don't really see that in here. I don't really see either one of those. Next it says calculate the skewness and kurtosis values of each of your columns of data, for the 3 quantitative columns of data. Use the skewness values to determine whether each of the 3 columns of data has a negative skewness, a positive skewness, or roughly no skewness. You can go back to the spreadsheet right here. Under here I'll type in skewness. I'll go up to formulas again and go to statistical. Skew is for skewness. SKEW. I'll highlight number of siblings. Once again, I don't highlight these numbers down here. I click OK, and then I drag it across. Now, as long as a certain value is between -1 and +1, it's considered roughly no skewness. So these two would actually be roughly no skewness. But this one goes beyond +1, so it's actually considered a positive skewness. So these two have roughly no skewness because they're between -1 and +1. And this one is considered a positive skewness because it goes above +1. I mean, it reaches +1 or higher. So I would say number of siblings and number of TVs owned. have roughly no skewness, and commute time has a positive skewness. The -1 and +1 cutoffs are really just a guideline for deciding if the data has a noticeable type of skewness or if it's roughly no skewness. So I'm using that guideline here, and I'm saying that commute time has a positive skewness. It also says to use the kurtosis values and make the same decision about kurtosis. Is it negative, positive, or roughly no kurtosis? So we'll go down here and type in kurtosis. I'll go to more functions, statistical, and I'll go down to KURT, Kurt right here, and I'll highlight these numbers. Now I have my kurtosis values. These two are both between, they're between 0 and -1. They don't go beyond -1. So even though they're negative numbers, they would be roughly no kurtosis. But this one is actually a large positive kurtosis because it is definitely it definitely reaches +1. Well, I mean, it's definitely outside of the -1 to +1 range that's considered to be roughly no kurtosis. So I would say this is positive. So number of siblings and number of teams owned, roughly no kurtosis. And commute time has a positive kurtosis. So remember the guidelines that I showed you before? It looks like this. This is where you get a negative skewness. This is where you get a positive skewness. And in between is where you have roughly no skewness. And kurtosis follows the exact same guidelines. So this one, it follows the same guidelines, so anything in this area would be considered a positive kurtosis. Let's see if we finish this question. Oh, are any of the three columns of data close to normal, meaning close to a normal distribution? It's close to normal if you have roughly no skewness and roughly no kurtosis. So if both skewness and kurtosis are between -1 and +1, then you can say that it's roughly normal. Let's see if any of these are like that. Number of siblings is close to normal because both values are between -1 and +1. The same thing for number of TVs owned. They're between -1 and +1. This one is not close to normal because both skewness and kurtosis are outside of the -1 to +1 range. And actually, if one of these values was outside and one of them was inside, for example, if I had -1.97 for skewness and 0.65 for kurtosis, I would still say it still wouldn't say that it's roughly normal because one of these two values is beyond -1 or beyond +1. So I'll undo what I just did. So now I just mentioned which ones are roughly normal. And if none of them were roughly normal, I would just say none of the three columns of data were roughly normal. This next one says create a scatter plot for each possible pair of two columns of data. Oh, one thing I wanted to say before that is this question number 4 is only asking you to answer based on the values. For example, you're not answering question 4 based on what the histogram shows. You're only using the values to decide what your answers are. In question number 3, I'm asking you to just use the histogram and use your own judgment to decide what the shape looks like. And if question number 4 gives you a different answer than question number 3, don't change your answer to question number 3 because question number 3 was I just want to see what your own judgment was before you actually calculate the values. So you don't have to go back and change your answer to 3 if your answer to number 4 comes out differently. So let's create scatter plots. First, let's do it for siblings and TVs. I highlight both columns. I go to Insert. I go to Scatter. I can highlight this one right here, the top left, and it gives me a scatter plot. I don't think I'm going to have you label the X and Y axis because I don't actually see a place to actually put those labels. So this would be fine. Actually, what can you do with this? Format axis. I guess I'll just have you leave it this way. And when you make a scatter plot, it actually gives you the scatter plot inside of the same spreadsheet that your data is in. So if you want to, what you could do is just make it smaller so that it fits on the same page that your data is on. That way it'll print out the scatter plot and your data together. If you click here, you can drag it in to make it smaller like this. Now I'll do it for siblings and commute time. I can highlight this. I press Control and I highlight commute time. Now I go to Insert and Scatter. I have another scatter plot. I'll move it down here. Oh, I have to click outside of the lines in the white area, and I can drag it down like this. And now I can click on this gray area and make it smaller. I think I can. Oh, you have to go in the middle right here where these little dots are to actually move it in. And then up here, at this spot right here. Next I'll do TVs and commute time. I'll drag this down. Now they all fit on my spreadsheet. Down here. I think this is the easiest way to do it. This one I have to move up just a little bit because I think it's getting cut off at the bottom. Now what can I do? It asks, describe whether each scatter plot is showing, looks like it's showing a negative correlation, a positive correlation, or no correlation. So now you just have to look at the graphs again and make your own guess. I would guess that this one looks like it's maybe no correlation because it drops here and then it goes back up and it doesn't really look like it's rising or falling. This one right here, I would guess positive because it's rising. We have this one dot up here, but it still looks like it's pretty much rising from left to right. This one over here looks like pretty much no correlation. It's just a triangle of dots that goes up and goes down. So I would, in my answer, I would say number of siblings and number of TVs owned. It looks like there is no correlation between number of siblings and number of TVs owned. It looks like there's a positive correlation between number of siblings and commute time, which is my second scatter plot. And I said that it looks like there's no correlation between. The third one was number of TVs owned and commute time. Question number 6 asks you to calculate the correlation coefficients, which are the R-scores, for each of the pairs of data that you made the scatter plots for. So I just need to have one more row down here where I can show the correlation coefficients. So maybe I have to shrink this down a little bit so I have a little bit more room. This one is fine, but I'll shrink it down also. And here I'll put R-score, or you could say correlation coefficient. Now this is actually, I can't actually easily do it this way because each R-score doesn't go with one column of data, it goes with 2 columns. So what I should actually do is maybe over here I could make this wider. I could say something like number of siblings number of TVs. And then here I could say number of siblings commute time. And right here I could say number of TVs and commute time. And now I'll click right here. For number of siblings and number of TVs, I can go up to formulas again, go to statistical. Now I go to where it says CORREL for correlation coefficient. For array 1, I highlight siblings. For array 2, I highlight commute times. No, wait. I'm doing the first one. I'm doing siblings and TVs. So I highlight the B column for array 1. For array 2, I highlight TVs. Like this. Now I get the R-score. It came out to negative 0.09, which is it's pretty close to 0. And I actually can't drag this down the way I did before, because here I had the column set up in a way where I could just drag it across, but here I can't actually do that, so I have to go back up here, go to COREL, highlight siblings for array 1, highlight commute time for array 2, and click OK. And I'll do the same thing again. I'll highlight TVs for array 1 and commute time for array 2. Now I have all 3 of them. And I'll just, if you just show them in your spreadsheet in this type of a way, then that's fine. Oh, when I expanded this column, it made the scatter plot larger. Let's see if I can fix that. I can shrink it down again. bring this back over. And you don't have to set it up exactly the way I did, but I'm suggesting for you to set it up this way. I just want you to show it to me in a way that makes sense and it's easy for me to understand what you're saying. I just want to be able to see the three values, and I want to easily find out which one goes with which correlation. Like how you can easily see here which one goes with which. This one asks, is each one a strong negative, medium negative? Remember how in class we were talking about the rule where you have 0 to 0.4 and 0.4 to 0.7. So this is -1. This is +1. We have -0.4. No, this would actually be -0.7. Anything in here is a strong negative. Anything in here is a medium negative. And this right here is a weak negative. And then over here it's the same. It goes from weak to strong. I have the first one is -0.09 for siblings and TVs. -0.09 falls in here in the weak negative area because it's just a little bit below 0. Because you have to pay attention to the decimal places. Negative 0.09 is actually closer to 0. So if we had -0.1 right here, -0.09 or 0.9 would be a little bit closer to 0, maybe right here. So it's in the weak negative area. So I'll say this is a weak negative correlation. What about siblings and commute time? negative 0.008 is right about here. It's actually very close to 0. So it's in the weak negative area. The important thing to remember is to pay attention to the decimal places, because one easy way to make a mistake is if you confuse negative 0.09 with negative 0.9, or if you confuse negative 0.008 with negative 0.8. So what about negative 0.06? Well, if it was negative 0.6, negative 0.6 would be in here in the medium negative area, but it's actually not negative 0.6, it's negative 0.06, which is actually right about here. It's actually closer to 0 than negative 0.1, because negative 0.1 is negative 0.10, and our value was negative 0.06. So it's closer to 0. It's right about here. So it's a weak negative. Number of TVs owned and commute time is, I think it was a weak negative. They're all weak negative. And just like before with the histogram questions, you don't have to go back and change your answers to question 5. If your answers with question 6 to question 6 don't agree with your answers to question 5, then just leave your answers to question 5 the way they are, because question number 5 is just meant for you to use your own judgment in looking at the scatter plot, and question 6 is meant to have you use the values to decide what type of correlation you have. So question number 5, you only use the scatter plot, and question number 6, you only use the R-scores. Just like how up here, in question number 3, you only use the histograms, and question number 4, you only use the skewness and kurtosis values. So that finishes this part of the assignment, actually. So you can print out your answers, or you can either type in your answers like this, or print this out and write in your answers with a pen. And then to the back of that, you can staple your spreadsheet and the scatter plots. It's up to you if you want to include the scatter plots in the spreadsheet like I did here, or if you want to print them out separately and then staple them to the back of the spreadsheet. And also print out the histograms and staple those also. So you'll have your answers in Word, you'll have the spreadsheet with your answers under it like this, and then you'll have your graphs also stapled, your scatter plots and histograms. One thing you can do if you want to is click on copy and then go to Word, and then click on paste and paste your graphs into Word and print them out that way. The rest of this assignment is a survey. They just ask you, the first few questions ask about your understanding of some of the concepts we talked about last week. I was asking you to read the explanation of confidence intervals that I just uploaded yesterday and answer these questions. And each of these questions is just asking you, after reading my explanation of confidence intervals, which one do you feel is true for you? And 4 of these questions all have to do with that write-up of confidence intervals. Right here, I was thinking that I'll upload a video, I'll try to make a pretty short video on some of the material that we'll talk about in class next week. And I'll have you answer a survey question about it. The video probably won't be longer than half an hour, maybe 20 to 30 minutes. And then that'll be the final question. You can find that when I upload that video, you can find it in the Webleyography section.